Hello everyone, welcome back to the database course. Today we'll continue with the query language. I have received some of you guys, not all of you, have sent me the assignment. Please, I want you to take it more seriously. What you had to do last time was using the slides you were supposed to actually implement the queries, write down the query statements and show me the output of each query. Some of you did, some of you didn't. This is going to build up towards your grade, so you are all encouraged to please study the slides and implement the queries. And if you have any question, you can email me or you can write in a comment. You are free to do what you want to do, but please contact me and I will help you whether you have a technical problem or a problem in understanding. You were supposed to actually implement the queries, and then you had other two assignments on the travel database. You have till the end of this week to work on them and send me the screenshot of the output of your queries. So last time the last thing we were talking about was group by and the having condition and how we can put it all together, and we said how the evaluation of an SQL query starts actually by from, where you access the table. The table is present in memory, and then the where condition is applied. After that, a projection on the columns that you have in the select are going to be the only ones present, so you just keep those used in select, group by and having, okay? And after that, you do the group by, thus removing more rows, okay? And then the having, we eliminate some groups, and if you have the distinct, then you will eliminate also the duplicates. So that's how the SQL conceptually computes its result. Today we will start with multi-relation queries. Let me put it in slideshow mode. So multi-relation queries. In the multi-relation queries, we have queries on more than one relation. So the concentration was last time on a single table queries. Today we have select s.s name from, we have two tables here. So whenever you have two tables, you should actually join them with in the where clause. Okay, so here we have two tables, the S and an R, and whenever you have two tables, you have to actually join them using a key. Okay, that's present in both, in which they are going to be joined by. And that's the most important thing in querying on multiple relations. After you do that, then you put another condition if you wish for another column. And by doing this, we have talked about it earlier in the section of relational algebra. So when you select two tables from two tables, okay, what actually happens is that there will be a cross product of the two tables, in that each row in one table is combined with all the rows of the other table. So we're going to have a cross product between these two tables. For example, Bob will have this row here combined with each of these rows. So one row, okay, in sailors will correspond to 4 rows in this query. After that, after you join them, then you join them s.sid is equal to r.sid. In this case, okay, what will happen, for example, Popeye was linked with these 3 columns. What will happen when you join them on SID, we will only be left with two columns because the ones where the SID of sailors is equal to SID of reserves. This should be clear, yes, to all of you. Okay, this is how we think about it conceptually in order to figure out what the output is going to be. But how the query optimizer work, it's not going to work like this because it will actually be too costly. There's an optimized algorithms that actually do the same query but in a more efficient way. But to understand how it's being executed and what the output is going to be, we have to think about it in this way theoretically. Okay? So after combining the two tables, having cross product between the two tables, we have a big table whose size is equal to the number of rows here times the number of rows in the second table. Then when you join them on SID, you will be left with only a smaller group of them where, for example, Popeye will only be, this row will only be linked to two rows, okay, because where the SID are equal. And then for r.bid is equal to 102, we will only be left actually with those where the BID is equal to 102. And in this case, you will see that it's going to be, for example, one from Popeye and one from olive oil, right? So these two only have 102 as their BID. So you are supposed to actually implement it and check the result. So as we said, when you select from two tables, what actually happened, what you should think of is the Cartesian product of these two tables. And because we're only selecting S name, here you have the S name of sailors along with the reserves. So for each S name in sailor, it's going to be combined with all the reserve rows, okay, and columns. Olive oil as well. So each field in sailors is actually combined with each row in sailor is combined with each row in reserves. But because here we have select on s.name, we're showing only the s.name. Conceptually speaking, the semantics of this query, you can look at it as a nested for loop because the more tables you have, it's going to grow as if you have nested for loops, right? Okay, then the size would be this size times this size times this size times this size, and it will grow like that. And then you will have to do the condition. Upon the condition, you will get the output. This is a conceptual analysis. I'm just showing you here that the more tables you have, yeah, it's analogous to nested for loop. I talked about it once in class. It will grow in this way. It's going to grow quite a lot. Okay, but as I said again, this is not how it's going to be done by the query optimizer. The query engine will do it in a different way, but we have to think about it in this way in order to be sure of what the output is going to be without running the output. Okay, so in the exam, if you were asked to find the output, you should think about it this way and analyze it like that in order to figure out what actually is going to be the output of your query. So now join queries, so that's the detailed syntax in general of join queries, where you could have the where clause, the group by, having, and the order by. So all of these are also feasible when you have more than one table. So for example, to be more specific, so you can select, you can have a distinct, okay, the distinct keyword in order to have the output, to remove duplicates from the output. You have a target list, that's what you will see as your output of your query. from, and then here you will have the relation list. So this is in generally speaking, more than one relation, and here you have the join and the qualifications that you want. Okay, and as we said, the from clause will compute the cross product of these tables at this point. Okay, where we'll check the condition and discard some of the rows that fail these conditions, and select will project only the desired fields that you want to show. So by now this should be clear for all of you. Again, yes, and we said that if you have distinct, then you will eliminate duplicate rows. As I said, this is a straightforward way for you to understand how the query is going to be run and executed and what the output is going to be. But as we said, the query optimizer will find much more efficient ways of executing it. This slide, we have seen it before, and always keep in mind that in evaluating your query, we'll start from the from. This is the list of tables, and then you will eliminate some rows according to the where clause. You select, you actually project which fields you want to show, and then you do the group by, okay, and eliminating more rows, and then the having condition will eliminate some groups, and finally you can have the distinct to eliminate duplicates. An example here is find sailors who have reserved at least one boat. So how would we do that? Let's look at the query. So select s.sid. I want to see the SID from what? From sailors and reserves. And you have seen this by now that you can actually assign an as clause for which you will refer to sailors as s and reserves as r. Although you can use the keyword sailor, the word sailors and reserves, the names of the tables, but it's recommended to use the as clause and use variables instead. So I want to see s.sid, okay, where s.sid equals r.sid. So at this point, at the from point, you have the cross product of the two tables. At the where, okay, you only have those where s.sid equals r.sid. The question here, if you put select distinct, will this make a difference? Will it make a difference? I want you to figure out the answer yourself, but let me say it anyways. So you should know that because we said from here, okay, so there is a Cartesian product, and in the Cartesian product we'll show all the SIDs, all the sailors rows combined with all the reserves R, and then when we do the condition SID of S is equal to SID of R, will it show the duplicates? Do you think it's going to show the duplicates? Is there anything that would make it not show the duplicates? No, so the duplicates are going to show. So is it advantageous to put the distinct? Yes, we should put the distinct here in order to have only distinct, the distinct SIDs. Okay, in order not to have a repetition, or else we'll have the same SID happening twice. So in here we're doing the join again, but we're joining not only equality but only greater than. So can we do that? Greater than or less than, so we can join on different operations. And what's important here is to tell you that in here we should actually use this alias, which is x and y in here, because we're working with the same table. Okay, so the same table, we're joining on the same table, and then so we will have, let's say, Popeye with Popeye, olive oil, Garfield, and Bob. All right, with all the table again. So the cross product will be the table on itself. All right, and that's why to resolve ambiguity, we have to actually use, it's not optional anymore, but it is needed to resolve this ambiguity. where we have to actually give names to the two different tables. Okay, and the join, after that we're going to remove all the rows, the resulting rows that don't satisfy this condition. We'll keep only the rows, okay, the resulting rows that satisfy this condition, okay, which is x dot age is greater than y dot age, and the projection will be on the name and age of the first table and name and age of the second table. So the SID and the ratings will be removed, and the resulting table is going to have S name age, but there is one for table X and other for table Y. However, we don't have these tables, but these are going to be actually created for this query, okay, created locally for this query, and this is going to be your output. Again, I want you all to actually write it down and run it in order to understand it better. Keep in mind again that the from is doing the dot product and the where is removing the tuples that don't satisfy the condition. And again, instead of having an equal, we can have greater than, we can have less than, we can have greater than or equal, less than or equal. What about arithmetic expressions? We have talked about it in the previous lecture as well. Okay, so we can have arithmetic expressions in the select statement, we can have arithmetic expressions in the where clause. So in here you have them in the select statement. So in the selection you have to, because of having this format over here, you should know that the result will be the age. The result that you will see is a table with age 1 and with age 2, where age 1 is actually s dot age minus 5, so this age minus 5, and age 2 column will be s dot age times 2. Okay, so we're always looking at the sailors because the sailors is the one that has the age column, the age field, where s dot name equal Popeye, so it only is going to show me, okay, one row, and this is going to be the titles of the row, H1 and H2, and it's going to be Popeyes. In here we have another way of doing this, okay, but now we have arithmetics in the where clause, all right, and we have a different thing here. We are only projecting those that have their 2 times rating equals to the 2 rating minus 1, okay, from one table, and this is from the other table. Of course, that's not sufficient with the same value. So what you do here is that you're going to project the S name as name 1, so you will see in your output a table column. The first column is name 1 and the second column is name 2, and they're actually coming from the same table S but different names. So sailors as S1, sailors as S2. Again, we are getting a cross product of the same table on itself because we're working on the same table. All right, so we're looking at the sailors themselves, where we have this relation valid. So it will show me then 2 names, okay, name 1 and name 2, where this condition is valid. So first of all, it's going to combine all the names with each other in this from, in the joining, and then on this condition, it will remove all the rows that do not satisfy this condition, and it will always project only on the names from the table itself, because it was actually cross product with itself. To understand better, again, it's very essential that you actually write down, run it, and I want to see this working, and I want to see your output, or else I will have to do an exam. So you have 2 options, either a quiz or you actually, the most important thing to me is for you to understand how these queries are running. So it's more important for me that you actually write it down and run it and look at the output and send it to me, instead of actually going through a quiz. So this grade, you can get a full grade on that if you actually do it fully, okay? This is going to be you have all next week for that. this assignment. Now, an important thing about SQL is the flexibility in string comparisons, in that if you have a string data type, okay, you don't really have to compare it only with equal. You can use the like keyword, which allows you to use regular expressions, okay, in that the S name shouldn't be exactly, you shouldn't know exactly how it looks like. You can have it uppercase, lowercase, so this is flexible with regular expression. For example, in this query, we are checking if the S name starts with a uppercase P and then any character here. It has to be one character, so the underscore indicates one character, then a small p, a lowercase p, and then any number 0 or more characters, that's the percentage. Very interesting. That I will give you a link for which you can go and review more regular expressions which can be used in your project. Now we have, let's look at this query here. We want to find the SID of sailors who have reserved a red or green boat. So as you can see, we can use the logical operators and or, and we have other keywords like union, except. We will look at them together in this lecture. So if you want to have the sailors who has reserved either a red or a green boat, so intuitively you would use the or keyword, and that's what we do here. We're actually combining the two tables, reserves and boats, okay, because I want the SID of the sailor. So I'm going to project on the SID of the sailor from the reserves, and then I'm going to check the color of the boat from boats. Okay, so to do that, you have to join on equal. So I'm going to check only those who have the same BID. So I'm checking now the characteristics of both that are present in the boats relation, okay, for this boat ID. Okay, so r.bid is equal to b.bid, and I'm going to actually present those sailors who have the boat color equal to red. So I get it from this join here. Okay, so we join the BID, the boat that the sailor has reserved, with the boat specifications from the boat table, and I'm going to look specifically at the color of the boat. So in here we check if b.color equal red or b.color equal green, and you can actually use or, okay, and you have brackets here. Another way of doing the same thing is, again, I want to see the SID of the sailors who have reserved boats that have red. So in here I'm going to join on the boats in order to see the specification of this boat, specifically the color of the boat, that's red. And I can use the keyword union all, so it will combine, because the result of any query is actually, in this case, it's actually a table. Okay, so I'm going to actually join these two relations. Okay, so the second relation is going to be those who have B color, the boat color equal green. So we have two options. So in this example, we were introduced to the or and the union all keywords. Now, if you want to find SID of sailors who has reserved a red and a green boat, yeah, so a red and a green boat. So I want to get r.sid. So that's the sailor's ID, okay, again from boats reserves, from relations reserves and boats, because I want to look at the specification of boat, which is red. So I'm saying here b.color equal red and b.color equal green. So after combining the two tables and getting the rows on the same boat ID to check the boat specifications for each sailor that was reserved by each sailor, I'm saying here that b.color equal red and b.color equal green. Is this possible? So you would figure out that this is not possible. There has to be another way of doing it, because the color cannot be red and green at the same time. So another way of doing it is using the word intersect, okay, where you will have the intersection of the resulting two tables. Again, this is possible because each query answer is a relation. So you actually, what you do is you find the intersection between these two relations. In this case, the relation that will be output is only the SID of those who reserve the red boat. So the result here is an a table of SIDs, and here also table of SIDs, and we are going to get only the result of both is actually the SID that appeared here and here. That's the intersect. Okay, and that's how you resolve the problem with AND. Another way of doing it is in here too. So in here, we're joining the same table, the same two of the two tables and two of the two tables. So we're joining on both B1 and both B2. Reserves are 1 and reserves are 2. And here we have 4 tables. We did that self-join so that we can say B1.color is equal to red and B2.color is equal to green, where the join is on R1.SID and R2.SID, where R1, so the both of R1, okay, we get the specification of R1, which is B1, and of R2, which is B2. So there has to be 2 columns for this sailor. Okay, first of all, this sailor there were 2 columns, and then we check on both columns. We check if one of them is red and the other is green. However, the other ways are more straightforward and simpler. Now let's look at this query. We want to find SIDs of sailors who have not reserved a boat at all. So what we're using here is the keyword except, in that the result of this query minus the result of this query will give me those who have not reserved a boat. The first query will give me all the sailors. The second query is giving me those who have reserved the SID, also the same sailors, but these are the sailors that actually had reserved a boat. Okay, that we had this condition satisfied, which means they have reserved a boat, and I'm going to have the result of the relation which resulted from this query minus the relation that resulted from this query, and actually the result will be those who have not actually had this condition true. So this is using the word except. Now nested queries, we have seen and you have used nested queries in the previous lecture. What we're going to use nested queries in here is using the keyword in. Okay, so we're looking at the names of sailors who have reserved boat 1 or 2. One way of doing it is having a nested query, and in this case, again, we are selecting only, want to see only the S names of these sailors from the sailor table. Okay, now I want to get to the boats. So where S.SID, the SID of this sailor is in the resulting table of this query. And this query says select the sailors who have actually reserved a boat. Okay, but which boat? The boat with ID 1 or 2. And so this is going to give me actually the sailors who have actually reserved boat 1 or 2. Again, to see this more clearly, I want you to write it down, run it, and show me the result. You can alternatively use not in. Okay, so only we want the names of sailors who have not reserved boat 1 or 3. So you do the same thing, but in here you have the keyword not in. Interesting keywords that you can use, and it will simplify your queries. Now we can have nested for loops, nested queries. Yeah, we have here nested queries, but with correlation, in which in the second query you actually refer to a table in the first query because it's already present in the query. Okay, so in here what are we getting? We're getting the names of sailors who have reserved boat 1 or 2. So we joined actually on SID, and we use the word exists. Exists, this means this shouldn't be null. Okay, so any value that is present here, select any. So if this exists, then okay, for this sailor, if this exists, if it's not equal to null for this, for each sailor in this table, I'm going to show the S name. Okay, and this query will actually give me those with the boat equal 102. So intuitively, this is going to show me all the sailors who have actually reserved boat 102. Okay, so we are here joining a table from this query with a table from the first query. Okay, if you write it down, you'll see that it's going to work. So we have seen in exists, so you can also have not in, not exists. Okay, we have seen not in, there's another one called not exists. We can also use any and all with an operation before them, let's say greater than any or less than any. Okay, greater than or equal any. All right, so the any keyword is also present. So these are more options that you can add to your knowledge about the query language. So in here, for example, I want to find all the sailors whose rating is greater than that of some sailor called Popeye. So I want to see all the sailors who have rating greater than the rating of Popeye. So to do that, we can have nested queries and using the any keyword. It's an option, and it's an easy option actually. So greater than any, and then select. So as you can see, when you have greater than, you should have the same, comparing with same data type. So in here s dot rating, and here also s dot rating. Okay, but we give it a different name, sailors s2, so that we don't get mixed up between s and s2. If we used s here, then we will have a problem. So you had s2 from sailors s2, where s2.sname equals Popeye, and we use the keyword greater than any. Now a tougher query, here we're going through more tougher queries. I know some of you guys like to challenge themselves. So for those guys, you can look at these slides, write them down, implement it, and also send me the result. We're here using 3 queries. Again, let me tell you here that you are not responsible of those because they're a little bit more complicated than usual. Okay, so this is only for the guys who like to challenge themselves into tougher queries. A very important function that you can use is max. Okay, so for example here, if I want to find the sailor with the highest rating, I can use max in the select statement. It looks like the aggregate functions that we have used, but in here what we're doing is using the max function, which will give me the maximum S rating of sailors. This would work, but this one here will not work because you can only have only one. If you are selecting on max, you can only select on max. You cannot select with s dot star. This would confuse and will not give you a correct answer. So you should have max only. Another way of doing this is this way. You can actually select star from sailors and check the rating, which is greater than all. So if it's greater than all the ratings in S2, okay, S2 dot rating from sailors S2, so you actually, for each tuple, so for each sailor here, you're checking it with all other sailors and the sailor itself, because S2 will have all the sailors, but that's why we have here greater than or equal, then this will give me the maximum. Or will this show me ties for highest? What do you think? If you, it's not undeterministic, it's deterministic, because you know how it works. Because you know how it works, you should know that it will go through all the sailors and check the S dot rating, so it definitely will show you the ties. Okay, that's another way of doing it. Okay, we are using here also nested queries. So, and you're using equal here, and you have select maximum S2 dot rating from sailors S2. Here, this one here will not show you the ties because you're selecting star from sailors. We're using the order by rating, descending, and showing only one. So this should show me only one, only the highest. So it will not show me tags on this one. Again, every query, please implement it. Now, the last thing I want to talk about are the null values. We know that in SQL and databases, you have null values. Okay, so these null values has to be treated in a different way because they're neither true nor false. So we have to look into a three-valued logic, which is true, false, and unknown, and that's the truth table. For that, for example, if you have P equal Q, P was unknown and Q was true, then the answer is also unknown. If P was unknown and Q was false, the answer is unknown of P equals Q. If they're both unknown, also P equals Q is unknown. So this is a little bit confusing, but you should know it. This is the most important thing. The other one is common sense because it's or and yeah, or and that's much easier. So the equal is the one which is confusing. Whenever you have unknown in an equal, it's always going to be unknown, whether the other one is true, unknown, or false. All right, again, we will have another lecture more on query language, more topics to address. Please, any question you have technically or theoretically, you can send me an email or write it in the comment. And again, if I don't see all of the class responding concerning the assignments, I will have to do an exam, okay, for as a midterm. Okay, so the work that you do throughout the assignments is going to add up, substitute your midterm exam. Please do it, and I want the response from everybody. All right. Have a safe weekend, and again, I want to remind you that you have all this week to finish up with the pre-posted assignment, and most importantly, the assignment on the slides that you have to actually implement the queries and have screenshots of them. Okay, thank you.